Right, so this is problem 2.4.29, and they give us this rather crazy looking Venn diagram. And then they ask us specifically, the question is a little interesting. They ask us to find the numbers of the regions belonging to each set. So they're actually not asking for the number of elements which in each set, which is usually what we ask. They're asking specifically for the actual numbers that exist in each of these sets. Okay, so because of that, because of the way that they're asking this question, I think it would be easiest if we first of all just go ahead and identify what are the elements that are existing in each of these sets. Okay, so I'm going to kind of fold this so we can see the Venn diagram, and we'll come back to each of those problems separately. So let's do, first of all, let's just go ahead and take a look at the elements that are in each of these sets. So in set A, that's going to be any number that's in set A. And set A is the blue here, right? So we've got an 8, an 11, a 9, a 10, a 2, 16, 3, and a 6. You don't have to list them in any kind of order, right? So what I'm seeing here is an 8, an 11, an 8, an 11, a 9, a 10, a 2, a 16, a 3, and a 6. All right, in set B, I'm seeing a 14, an 11, a 9, a 12, a 4, a 16, a 3, and a 7. You kind of have to use selective attention, selective focus, because there's so much going on. You're just looking for the elements that are existing inside, the red, and so you kind of have to just ignore all of the other lines if that's possible. Okay. So in set C, that's everything inside the green circle there, I see a 9, a 12, a 13, a 10, also a 4, a 5, a 16, and a 2. And then in D, region D, which is the black region here, I see a 5, a 4, a 16, a 2, a 7, a 3, a 6, and a 15. Okay, so because they're asking us to work with these numbers, then it's actually easier if we just list out what's in all of these first, and then go back and try and take a look at what they're asking us to do. And we'll also need to know in this problem what the universal set is. So the universal set is everything. What are all of the possible numbers here? And that's all of the numbers counting numbers from 1 out to 16. Okay, this is a little crooked. Okay. So let's go back now, and we can actually just sort of ditch the picture now, and we can just work with this to answer these questions. So let's go ahead and answer these questions. In part A, they're asking us to identify, it's a little hard here, the webcam doesn't get as wide of a view as I'd like it to. So A intersect B, intersect C, intersect D, okay? So what we're looking for then, remember with intersection, is we're looking for what elements do they share in common. And if you look at all of these, and we're not looking at the universal set right now, we're just looking at A through D, all of these, and compare what do they share in common, you're actually going to see that the thing that they share in common is the 16. And that's it. They don't all share anything else in common. If you went back to the picture here, you can see that right here, right? So this 16 is the only number that has red, blue, inside the black, and also inside the green, okay? So to list this particular one out, the intersection of all of these sets would be the set containing the element 16. All right. So the second problem here, they were asking us to identify the union of all of these sets. Okay, well, the union is just taking everything in these sets and putting them together into one set. And again, in this instance, the picture might be helpful. The only element that isn't existing in one of these sets is actually this number 1 right here. That's on the outside. So that's in the universal set, but not in any of the other sets. And so what we would do here is we would actually say it's everything except that one. I think in the problem, so if we were to list it out, it would actually be listed like that. But I believe in this problem in the homework, they're actually asking you, they give you a multiple choice. And one of the selections is all regions except one. And that would actually be what the solution would be for this problem because it's everything but one there. All right, so part C, they are asking us to identify the intersection of A and B and then union that with the intersection of C and D. Okay, so this is an example. C and D are both examples, the part C and part D are both examples of where it's just really cumbersome to look at this picture and try and figure that out. It's going to actually be much easier to look at the sets that we have identified here and work with it that way. So let's go ahead and identify first of all the intersection of A and B. So remember that the intersection is what do they share in common, what do they share in common when we're talking about intersection. So let's look. So let's see, we've got an 8 in A. Does B have an 8? No. Looks like they share an 11 and they share a 9. So let me go ahead and start making a list here. So 11 and 9. I'm looking at this right here now. Do they share a 10? No. Do they share a 2? No. A 16? Yes, they do share a 16. They share a 3. And that's all I see. If we check the 6, they don't share. 7, they don't share. I mean, you can run through the lists. So this is what I see. I see them sharing those elements right there. Okay, we're going to take that and we're going to union that with the set of the intersection for C and D. So if we compare C and D and look at the intersection there, what do they share in common? Do they share a 9? No. A 12? No. 13? No. 10? No. They do share a 4. They do share a 5. They do share a 16, and they do share a 2. So it's actually those last 4 there. So 4, 5, 16, and 2. Okay, so now we're going to go ahead and actually just combine these, right? Because it says the union there. And so the union is just taking all of these elements and putting them together into one set. And it doesn't have to be in order. But you don't want to list multiple elements or repeated elements. So the 16 we're only going to list once. Okay, so that would be the answer there for part C. All right, and then in part D, they are asking us to identify, I don't remember, let's look. So A naught intersect B naught intersect C union D. Okay, so again, we're just going to go ahead and work with these separately. Let's go ahead and identify that, and then we'll go ahead and identify that, and then we can look at the intersection. So if we're looking at, if you're not in A and you're not in B, and we're looking for the intersection. Need my union there, or my universal set. Okay, so if you're not in A, let's list all of those. So A naught is going to be, let's see, there isn't a 1, right? So when we're looking at the negation or the not, we're looking for everything that's in the universal set that isn't in A. So I don't see a 1 in A. I see a 2 and a 3. I don't see a 4. I don't see a 5. I see a 6. I don't see 7. 8, 9, 10, 11. I don't see 12 or 13 or 14 or 15, and I do see a 16. Whoops. Okay. Part B here, B naught. So if we look at what that one doesn't have, it doesn't have a 1. It doesn't have a 2. It does have a 3. It does have a 4. It's hard for me to get all of this in the screen there. So 1, 2, it does have a 3, it does have a 4, it doesn't have a 5, doesn't have doesn't have a 6, does have 7, doesn't have 8, does have 9, doesn't have a 10, does have the 11, 12 and 13 are missing, has a 14, and it's missing the 15. Okay, so now that we know those sets, we can take a look at the intersection. So A naught intersect B naught. They share in common a 1. They don't share the 2. They do share the 5. They don't share 4 or 7 or 6 or 8. They do share a 12 and a 13. Excuse me. And a 15. Okay, so what we want to do now is take this and intersect it with the union of C and D. So the union of C and D, what I see for those elements. So we've got I'm going to go in order this time so that I don't repeat elements. So I see a 2, a 3. So a union, we're just combining it all together, right? 4, 5, I see a 6. I see a 7. I don't see an 8 in either one of them. I see a 9 and a 10. I don't see the 11. I see 12, 13. I don't see 14, and I see 15 and 16. All right, so now what we're doing is we're taking these two sets and we're looking at the intersection of them, okay? So that means, what do they share in common? So they don't share in common the 1. It does look like they share in common the 5. They do share in common the 12 and the 13 and the 15. Okay, so to answer this question then, it would be the set containing the elements 5, 12, 13, and 15. I feel like somehow I made a mistake there. Well, let's look. Oh, yes. B naught. That's a mistake. So B does have a 12 in it. Sorry about that. So B does have a 12, so let's take that out. So this would come out of that right there. And then they would not share in common the 12, so this would come out. Yeah, I'm sorry about that mistake. Hopefully you caught it. So 5, 13, and 15 would be the solution to part D there. Okay, that's it on this problem.